Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 10, Conditions for a Unique Triangle. Two angles and a given side. A, S. Alright, exploratory challenge 1. A triangle XYZ has angle measures angle X is 30 degrees and angle Y is 50. So therefore angle Z is, quick, 100 degrees. Triangle sum theorem, 180. 30 plus 50 is 80 plus 100 is 180. Alright, and the included side XY, the side between angle X and angle Y is 6 centimeters. It says to draw a triangle X prime, Y prime, Z prime under the same conditions as X, Y, Z. Leave all construction marks as evidence of your work and label the side and angle measurements. I'm going to start off with a ruler, and it always puts it way up at the top. And I need what? Oh, I don't know. Let's just do the ruler first. And we'll get to other things next. So obviously if you're going to create an angle, you are going to need two rays. And I know that there's a side XY that's 6 centimeters, so I'm going to start with that. So I'll draw a side XY at 6 centimeters in length. So I start at 0 and I go out to 6. Okay, fairly close, pretty good. Alright, so I'll move this and I'll label that 6 cm. This is going to be X prime over here, and this is going to be Y prime. So if I put a dot at the end, those would be our points of the endpoints of our line segment XY prime. Okay, so now I need an angle coming off of X. So I need a ray that will make a 30-degree angle. So I get my protractor and I put the crosshairs as accurately as possible on the point X prime so that my side is right on the 0 degree line of the protractor. And then I come out 30 degrees, which is right here, and I'm going to place a dot right there, and that is where I'm going to draw my segment from X up. So I put my ruler there and I set it at, okay, right about there. I'll make this green. I don't know how long it's going to be, so I just draw a ray out. Okay, so it's a ray. Okay, so there's a ray X, and Y is on there somewhere, so I can call it XY in a moment. Or XZ, I'm sorry, Z. Z is on there somewhere. Alright, so now I need to make an angle. So that was my 30-degree angle X, so I'm going to label that 30 degrees. Okay, pretty simple so far, I hope. And now I'm going to create an angle Y of 50 degrees, and that means that I need an angle coming this way, a ray coming this way to form an angle at 50 degrees. So I put my crosshairs right on Y prime. Make sure this X segment XY prime is right on the 180-degree line of the protractor. And then I find 60 degrees, so I'm going this way, so I want this 60. So I'm going to put a dot up here. Move my protractor out of the way. Bring my ruler around. And I'm going to place that right on Y prime as accurately as possible and draw a line segment through that point right there. So there is my other ray, and that created a point of intersection, and that is Z prime. Okay, so my triangle's created. This is 60 degrees. I shouldn't have to measure this because the triangle sum theorem says that angle A plus angle B plus angle C equals 180 degrees. And since I have two angles that add up to 90, oh no, that's not 60, it's 50. My fault. This is 50 degrees. So if this is 50 degrees and this is 30 degrees, Okay, so I did that wrong, didn't I? Did I do 50? Did I do 50? I did 60. That's what I thought. What is wrong with me? Oh, the humanity. All right, so anyhow, let's just ignore that, and we're going to ignore this dot. I'll get rid of it after I'm out of the way. I wanted 50 degrees. Must be too early for me to be doing this. So here's 50 degrees out here. Okay, so I want to get rid of this dot. All right, so I want 50 degrees, not 60. I don't know where that came from. Anyway, if I draw a line segment from y prime through my point that's now 50 degrees instead of 60, then it will go through that point. So this is my segment here. Okay, finally, now this is z prime, and this is 50 degrees. So now that I have 30 degrees and 50 degrees, that adds up to 80. This must be 100 degrees. Now I can check it to verify. So you put your protractor right on the point, rotate the protractor so you are on one of the segments. I'll put it right on the green one. Okay. And I would say it's right about there. And if I then bring this around and measure this angle, I'm still off. There it is right there. So I'm right on that blue line, and sure enough, it is 100 degrees. Very good. Okay. Now I can continue and measure the other two sides. All right. So if I put this back here, that looks like 3 centimeters. So this is 3 cm. And then if I rotate this back to where I was supposed to be on the other side, 30 degrees, and I put that right at 0, and I'm right on that green line, and I count up to Z, that is 4.5 centimeters. So I will label that 4.5 cm. Okay, I did not take any marks off. I'm not going to erase anything. That is my diagram of the triangle x prime, y prime, z prime. That has a 30-degree angle, a 50-degree angle, and a side included between the two given angles of 6 centimeters. And that is angle, side, angle. Okay, so it says under what conditions is this drawn? So the condition on triangle x prime, y prime, z prime is the two angles and the included side condition. Okay, two angles and the included side, which is called angle, side, angle, ASA. All of the triangles are identical. The condition determined a unique triangle. After drawing the included side length, I used the protractor to draw the provided angle measurements at either endpoint in the included side x prime, y prime. Since these two angle measurements are fixed, the two remaining side lengths will intersect in one and only one possible location, which is the third vertex of the triangle Z prime. There is no other way to draw this triangle, therefore the condition determines a unique triangle. Okay, number 2. A triangle RST has angle measure S is a 90-degree angle, so we have a right triangle. T is 45 degrees, and the included side ST is 7 centimeters. Draw R prime, S prime, T prime. So I'm going to start with my ruler, and I bring it down here, and I'm going to draw ST 7 centimeters in length. So I put my pencil here, and I draw out to 7, and that's pretty close, so I'll just leave it, 7 cm, and that is S prime, and this is T prime right here. If you want to put a dot at the end, I guess that's okay. All right, so there's my line segment ST, length 7 centimeters. Step 1 is done. Now I need to create an angle at S. That's 90 degrees. So I get my protractor, and I put it right on S. so that this line segment is right on the 0. I want 90 degrees, so that's straight up and down. So I want to come to a point somewhere up here. So I'll put the dot here above the print so I can see it. And then I rotate my ruler and put it right at 0 and draw a segment up to that point. Okay, so there is my 90-degree angle. All right. Now I need a 45-degree angle at T. So then I move my protractor here, put it right on T prime, make sure this segment is right on the 180-degree mark. I'll change colors. I'm looking for 45, which here's 40, here's 50, 45 is halfway between, and that's approximately there. Bring my ruler down to draw it. Okay. And I put the 0 right on there. It's going right through that point. Draw a segment up, and boom, and there's my triangle. I need to label that. This is 45 degrees. Okay. Well, triangle thumb theorem. Triangle sum theorem says that the triangle sum is 180 degrees. Or we also have another theorem that states that a right triangle's two other angles are complementary. So complementary means they add up to 90. So if this is 45, 90 minus 45 is 45. So this angle is also 45 degrees. And I need to label that intersection Z prime. That is right here. Z prime. Okay, so there's my right triangle. Now I need to measure the sides. So since I'm already at this angle, I'll put my ruler back. And that is 10 centimeters. Now ST is 7 centimeters. And since it's opposite this angle, then we have a theorem that says the side opposite two congruent angles are congruent. So without measuring, this should also be 7 centimeters. Okay, so if I put my ruler there, it's a little bit more than 7 for some reason. 7 is right here. Okay. So if I move that down so that it was 7, so this isn't totally accurate, but if it was, it's supposed to be 7. This has to be 7 because it has to be congruent to this side here. All right, so we have a Pythagorean theorem that says a squared plus b squared equals c squared. So I'm just taking this one step further. And since this is my a and this is my b, it'd be 7 squared plus 7 squared equals c squared. 49 plus 49 equals c squared. 49 plus 49 is 98 equals c squared. So c equals the square root of 98. Well, the square root of 100 is 10, so this would be slightly shorter than 10. And sure enough, if I rotate that down to this point here and it came to here instead of up here, it should be just short of 10 centimeters. Okay, so 10 centimeters is an approximation. All right. Okay, so under what conditions is this drawn? Okay, the condition on triangle R prime, S prime, T prime is the two angles and included side condition. Two angles and the included side. When it says included, it has to come between. ASA. All of the triangles are identical. The condition determined a unique triangle. After drawing the included side length, I use the protractor to draw the provided angle measurement at either endpoint of the included side S prime, T prime. The intersection of the sides of the angle is the third vertex of the triangle R prime. Why did I use a Z? It's R. Okay, RST, not ZST. All right, so there is no other way to draw this triangle, therefore the condition determines a unique triangle. And this right here would be more like 9.9 cm by the Pythagorean theorem. Hey Siri, what's the square root of 9.8?
The square root of 9.8 is 3.1305.
Oh, my mistake. Hey Siri, what's the square root of 98? Hello? Hey Siri, what's the square root of 98?
98 raised to the second power is 9,604.
Alright, she's just not listening to me. I'm not even going to waste more time, so let's move on. Okay, number 3 says a triangle JKL has an angle measure of J, 60 degrees. J, 60 degrees. Angle L is 25 degrees. What's the measure of angle K? Quick, quick. 105 degrees. Very good. And side KL is 5 centimeters. Draw a triangle J prime, K prime, L prime under the same condition. So this is just repetition of the same condition. I already have my ruler. I don't need this second one. So I'll bring this ruler down here. I will draw. I'll put it right here. KL first, which is 5 centimeters. So start at 0 and go out to 5. That's a little beyond 0. Try to be as accurate as possible. All right, 0 to 5. There. That is 5 cm. This is K prime, and this is L prime. Switch to red. Find a 60-degree angle. That is J. I don't have J yet. I have L. Okay, so they're giving us KL, and they're giving us angle L and angle J, which we don't even know where it is. So we can only do L right at this moment. So I'm going to put my crosshairs at L prime. Make sure this line is right on 180. And then I'm going to find angle L, which is 25 degrees. And that would be way over here. Put a dot, move the protractor, bring my ruler around. How many degrees are we doing? 25? All right. So if I put my ruler right at 0, right there, and go through that point, like so, then that angle is 25 degrees. Alrighty. Somewhere on this, I need a 60-degree angle. I don't know where. So, what are we going to do? Question mark. Okay, so now in order to construct this, the directions instruct the students to use, I don't even know if you guys have that in your school where you are, but it's called patty paper. It's actually like a transparent, semi-transparent paper. So what they want you to do is create an angle on patty paper. So I'm just going to do it here because electronically I can move my angle around like it's patty paper. So if you were to do this, you draw a line segment on the patty paper like so, and then you'd put your protractor on one end of your segment like so, so that it is, okay, there we go, perfect. All right. So I want to make a 60-degree angle. 60 is right here, so I put a dot right here. So this would be done on patty paper, remember? And then I rotate this up, and I am going to put my ruler right at 0. Okay, and then I'm going to draw my angle. That is 60 degrees. Okay, so now that that's created, I have a 60-degree angle. So if I were to use my patty paper and pretend that this is a piece of paper that you can see through, you bring it up over here and you set it down on top of your diagram, but then you would need to rotate it like so and put this red line right on top of the green one so they line up like that, and then you move it down until this red line here goes through the point K prime. So if I put my, patty paper down here, like so, that's pretty close right there. Okay, I'm just trying to be really accurate. There. Okay, so there is my triangle. That is, this is 60 degrees. This is 25 degrees. Now that's up to 85. So this angle is 105 degrees. Okay. So we also have to measure all the sides. So I know that this is 5 centimeters. So then I measure as accurately as I can this angle here, or this, not angle, but get it the right angle, and then measure the segment. So put that right at 0, and it looks like 25 or 2.5 centimeters. So I'll put 2.5 cm, and then rotate it around so that it's at 30 degrees. No, not 30, 25. All right, and put 0 right there. Mm. All right, so now I look, and that's 55, 56, 57, 58. That looks like about 59 or 5.9 centimeters. Measuring from here to here. Okay, and so there is our construction. Okay, so the condition on triangle J prime, K prime, L prime, this is J prime, is the two angles and side opposite a given angle, which is angle, angle, side. All of the triangles are identical. The condition determines a unique triangle. After drawing the given side length, I use the protractor to draw angle L prime, the adjacent to K prime L prime. So I drew KL and then that angle. I drew the angle opposite the given side J prime on a slip of paper and lined up a ray of the angle on a patty paper with one ray of the angle adjacent to the given side. I moved the angle on the patty paper along the coinciding rays until the free ray just met the endpoint of K prime L prime. So that meaning this segment here hit right there. There is no other way to draw this triangle, therefore the condition determines a unique triangle. Number 4. A triangle ABC has angle measure C equals, angle C equals 35 degrees. Angle B equals 105 degrees. That adds up to 140. So angle C is, let me do it in a different color. What's angle C? Or I'm sorry, not C, angle A. Angle A must equal the supplement to these two. 140 plus 40 is 180 degrees. So A is going to be 40 degrees. Okay, so and the side AC, which is 7 centimeters. So I get my ruler, I bring my ruler down, I put a dot at 0 and go out to 7. Perfect. 7 cm, and that is A prime. This end is C prime. Okay, hopefully you're getting the hang of this. It should be very quick after you've done a couple. Now I want to do angle C, which is 35 degrees. So I put my protractor as closely as possible to the point C prime, which looks like about right there. Okay, I want the angle 35 degrees at C. So 35 is right here. Move my protractor, bring my ruler around, and put my ruler right at 0. And draw my line segment through that point right there. Don't know how long it's got to be, so I'll go way up to the edge of my paper. So this is 35 degrees. Okay. Angle B is 105. It's up here somewhere. So I need to create an angle B on patty paper. So this is my pretend patty paper now. So I draw a segment of any length. It doesn't matter. Bring my protractor down and put it at one end. That also does not matter. But make sure your crosshairs are right on that end point. Like so. I need to move it down just a hair. Just a smidgen. Right there. Okay, I want this angle to be 105 degrees. So I'm counting this way to 105, which is halfway between 100 and 110. So it would be right here. Okay, so then I draw a segment there. Through the point here, up through there. Okay, so there's my angle. That's 105 degrees. I now have it on my pretend patty paper. I'm going to rotate it around so that this green line here is going to be right on top of my red line. So you adjust your patty paper so this lands right on the red line like so. Need to rotate it just a hair. That looks pretty good right there. And then I need to move it until it goes through the point A prime, which would be right here. So there's my triangle. So I'm now going to label it. This angle here is A prime. That is 40 degrees by the triangle sum theorem. And this angle here is my angle B, which is 105 degrees. Oh, I did that wrong. Didn't I? How do I know? Because that's acute. That wasn't very cute. So let me get rid of that. Oh, it killed me. Okay, anyway. Rotate this so that we have a 105 degree angle. So I need this side. Does that look obtuse now? Okay. So that I line this leg up. So notice what happened. I'm kind of glad I did that so I can explain this. If you use the wrong ray to line up, then you're going to get the supplementary angle to what you want by mistake. So now I need to move this down until I get it to intersect at A, which is right here. Let me use my arrow command. It's easier. Perfect, right there. All right, so now that I've done that, this is 105 degrees. It is obtuse. It makes sense to me now. So whenever you're doing your homework or doing your lessons in class, always ask yourself if your answer is sensical. Does it make sense? Is that sensible to me? Can that happen? And if it doesn't, then fix it. Okay, so that was, and now I know angle C is 35. Angle B, which is right here, B prime, I want it in green. B prime is 105 degrees, and angle A prime was 40 degrees. Okay, so that's 40, that's 35, and that is obtuse, 105, greater than 90. So now I need to measure the two sides, and we are done until we get our explanation anyhow. So I put my 0 here, and I measure from here to here, and it looks like 4.6 centimeters. And then I bring my ruler over here to A, rotate it so it's right on the green line, and 0 to here is, it looks like 4, so I'll put 4 cm. Now I also check to make sure that makes sense. My smallest angle is 35, so my shortest side should be opposite, and 4 is shorter than 4.6 and 7. My second longest side is 40 degrees. 4.6 is between 4 and 7. 105 degrees is my biggest angle, so the side opposite must be my biggest side. 7 is more than 4.6 and 4. Okay. So here's our lengthy response. The condition on triangle A prime, B prime, C prime is two angles and then opposite side a given angle condition, which is angle, angle, side. All of the triangles are identical. The condition determined a unique triangle. After drawing the given side length, 7 centimeters, I used a protractor to draw C prime, which was 35 degrees, adjacent to A prime C prime. I then drew an angle opposite the given side B prime on a slip of paper, patty paper if you will, and lined up one ray of the angle on patty paper with one ray on the angle adjacent to the given side. I moved the angle on patty paper along the coinciding rays until the free ray just met the endpoint A prime C prime. So I moved it until this segment hit right there. There's another way to draw this triangle. Therefore, the condition determines a unique triangle. And that, my friends, is the end of Lesson 10. Review this lesson summary of 3 sides, 2 sides and an included angle, 2 angles and an included side, and 2 angles on an opposite side. And go do your problem set.